All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. As I said before, when we were going over this in class, I apologize about not being able to get all the way through the entire lesson. But again, remember, with the shortened period, this is a great way to be able to get the full lesson that we're supposed to be talking about. So, with that being said, we have some terms that we need to go ahead and define, and I do want you to go ahead and write all these out on your paper. And then from there, after you've got the terms defined, I'm going to be honest, for the most part, it's going to be pretty simple. And so let's get right into it, define some of these terms. And most of these first couple at least, I'm hoping that you've heard of before. Now, we all know what a circle looks like, but what is the definition of a circle? Well, let me give it to you. It's all points in a plane equidistant from a given point. Okay, so again, all points in a plane equidistant from a given point. All right, so again, that's the definition of a circle. For number 2, the center of a circle, I just put in quotation marks, the given point. Okay, what are we referring to from the previous definition? Everything is revolving around one centralized point. Well, what is the center of a circle? It's the given point. Okay, we all should know what a radius is. Radius is the distance from the center to a point on the circle. So again, the distance from the center to a point on the circle. Okay. You guys probably already know what congruent circles have in common, and I would hope that someone earlier today said congruent circles are the same size. Yeah, well, that's based off the definition of congruent, but what makes them the same size? It's the fact that they have congruent radii or congruent diameters. So I'd like you to put that down. Congruent circles have congruent radii / diameters, one or the other. They've got to have one of those two things. Okay. Number 5, the diameter. The diameter is the distance from one point on a circle to another passing through the center. Okay, so that's the key there. The distance has to pass, this diameter length has to pass through the center. If it doesn't, we have another name for that in geometry. It's called a chord. Okay. Number 6, the central angle. The central angle is an angle formed by two radii within a circle. Okay, so again, an angle formed by two radii within a circle. All right, so what I'd like you to add to that definition, again, an angle formed by two radii within a circle. I'd like you to go ahead and draw a circle on your paper there. Okay, and then I'd like you to go ahead and draw two radii. It doesn't matter where they're located. Again, the radius has to go to the center. So I'll go ahead and do something like this right here. Okay, and I'll label their points A, B, and C. Okay, so if you're a visual person, angle ABC would be considered a central angle. Okay. Now I'm going to be honest with you, this next part is the most important part of today's lesson, okay? And so this is the key. When we talk about central angles, so I'm going to write down central angle, the measurement of the central angle is going to be in degrees, okay? So whatever the degree is of the angle, that's the central angle measurement, okay? Now, that measurement is equivalent to or equal to the arc measurement. Okay? And again, the arc measurement is also in degrees. Okay? So if you know one, you know the other. They're interchangeable. And so if I go up here and I go and say, yeah, well, this angle is 90 degrees, what do we know about this arc measurement? Well, it's also 90 degrees as well. Okay. Likewise, if you go over here to this angle measurement, that's 270 degrees. Well, guess what we know about the arc measurement? It's also 270 degrees. Okay? So just a couple of things to note that will be very, very important. It's very simple. And what I found in the past, students sometimes can forget because it is so simple. Okay? So from here, here's what we're going to do. The next thing is we want to determine the central angle for the following sections of the pie chart. And so what's basically asking is, for this first one, what's the measure of that angle right there? Okay. Now for a lot of you sophomores that did the World War II project, placing blame for the Holocaust, I believe is what it was, you remember, I hope maybe you remember how to do this. But here's what's happening. We have 11.9% of, I don't know if it was produce that was harvested or what, but 11.9% of this pie chart goes to green beans, okay? And so what we want to know is 11.9% of what? Now if you think about a circle, how many degrees would that be right there? Well, I hope you'll be thinking that it's 360 degrees. And so we want to know what is 11.9% of 360. In order to make that calculation, though, we have to convert this percentage into a decimal. And if you remember, in order to change it into a decimal, we want to move that decimal point 2 places to the left. So 11.9% is the same as 0.119, okay? And so as I go ahead and put this down, 11.9% of, in math is multiplication, 360 degrees will give us the degree of the angle at the center of the circle there. And so that's going to be 42.84%. Now, we've been dealing a lot with 45, 90 triangles. That's pretty close to a 45-degree angle. I hope that the answer there makes sense to you as far as the angle is concerned. If you get something like 120 degrees, you know you've done something wrong. Go ahead and take a moment and see if you can calculate out the corn central angle and the potato central angle. Go ahead and pause and see if you can do it. You can do it faster than I can talk you through it. Okay, well I hope that you were able to walk through that. For the corn, you should have 54.36 degrees. Again, I'll be looking for the work there tomorrow, so make sure you got that down. And for the potatoes, the tricky part about the potatoes, if I move that decimal point 2 places, make sure you have 0.088 as 8.8%, okay? But that one should be 31.68 degrees. Can guarantee you're going to end up seeing that concept again later on this chapter. So make sure you've got that down. Next thing we're going to do, we've got a couple more terms that I want to make sure that we've got defined for ourselves, and then we'll take a look at some practice problems. So the first thing I want to make sure we understand is, if I say the prefix semi, what should you be thinking? And I hope that you're thinking the word half, okay? I had someone ask me today, then why in the world do they call semi-trucks half trucks? I really don't know the answer to that, so if you have that, that would be great. Another person in that same group came up with the understanding that, what they say, well, you can take the back part off, and so it's half of a truck. I don't know. So just something to think about. Semi-circle, half. Now, if we're talking half of a circle, how many degrees is that? 180 degrees. Okay. Now, when you label these, and this is actually the important part of this section right here, you need to know how to label different arcs. And so you're going to use 3 points to label when you label a semicircle. Now, why would we use 3 points as opposed to 2? If you only use 2 points, then you don't know if you're referring to the top half or the bottom half, the right half, the left half. You know, you're just referring to a half. Well, which half are you referring to? That's why we use 3 points. So if I go ahead and mark this out, arc TRS, as you can see down here on this example right here, TRS would be considered a semicircle. Now, just like line segments, arc SRT is also the same arc as arc TRS. And so don't be confused if your letters aren't exactly the same, as long as you can trace the same arc with those letters. Okay? Minor arc is going to be everything less than 180 degrees. Okay, and we're only going to use 2 points for a minor arc. Okay. All right. So as we look at this middle one right here, for the minor arc, they give you the example of RS. That's a good example. I could also use arc TR. Those are both considered minor arcs. They're both less than 180 degrees, and so we can use those. A major arc is going to be greater than 180 degrees. And we are back to using 3 points to label this arc. Okay? And so an example of that in this last one, they give you arc RTS, which is fine. We could also use, let's see here, RTS, if I was to do TSR. That would be another one that you could use there. If you take a look for a moment, when you go ahead and identify an arc, I would put my pencil, my finger down on one point, and then go to the next point that's listed, and then we end up hitting the last point. And so that right there would be arc TSR or RST. Okay, both those are the same. For number 10, the adjacent arcs, remember what adjacent angles mean? Next to, okay? So here's what I'd like you to jot down for your definition of adjacent arcs. 2 arcs that share a common point, but no common interior points. Okay? So again, 2 arcs that share a common point, but no common interior points. So from there, let's go to the backside. Now, I'm going to be honest with you. On the backside, you could probably whip this out faster than I can even dictate it. Okay? And so as we look at the backside, what I want you to think, and if you just want to keep listening to me, that's fine, but always double check back. For number 1, CP, what would we call that of the circle there? Well, wouldn't that be considered the radius? Okay? AB, what would that be considered? It goes all the way across the circle, so that would be the diameter. Okay. For numbers 3 and 4, I can tell you what they are without even looking at the picture. And it's because it's listed as just 2 points. Whenever you have just 2 points, what type of arc is it? Excuse me. It's going to be a minor arc. Okay. And you can tell that right here. If I go ahead and show AC, that's less than 180. If we look at CB, that's also less than 180. Okay. If it had 3 points, then it would go on the other side of the circle there. Okay. Let's see. There it is. Okay. For number 5, arc CAB. Now CAB starts here, goes here, and then ends up there. So is that semicircle, major arc? It's a major arc, greater than half the circle. Okay. The last one starts at B, goes to C, ends up at A. That's a semicircle. It's a half circle there. Okay. So again, those are the terms that we just talked about, and I want to make sure you got those down. Okay. Now to continue on with those terms, I'm going to list lots of different things out here for all of these, and you can go any direction you want to. Okay. 2 minor arcs. Well, let's look here at the picture. Minor arc has to be less than 180. You could say AF, arc AF, AB, BD, DE, or EF. You could also say FD. You could also say DA. You could also say I couldn't say BF, sorry. BE. Okay. So there's lots of different arcs there, and you can just trace it with your finger. Any one of those, but again, an arc that's less than 180 degrees. 2 major arcs. Well, I could go EFB, okay, starting right here at E, heading to F, and then ending up at B, okay. But that same arc, I could say EAB, or BAE, or BFE. Okay, again, those are all the same arcs there. Okay. Another major arc you could have down, FEA, that would work. FDA, FBA, those are all the same arcs. You could do EFD or EAD, anyone that's greater than 180. So there's a lot of them up there. Two adjacent arcs. An example of that would be like arc FE and arc ED. Okay, the only common point that they have in common would be point E. Another example would be like arc AB and arc BE. Okay, those two would work. Okay. Two congruent arcs would be arcs that have the same measure. And so there's actually two sets up here. Actually, there's more than that, I think. You could have arc ED and arc DA. Both are 90. 90 here, 90 at the central angle over there. Okay. So those would work. You could also say EF and BA. Now the question would be, why are those two arcs congruent? Well, it's because their vertical angles are congruent. Okay. You could also go, was there another one I could use? Well, you could use the semicircle, FEB, BAF, ADE, EFA. So those ones there. You know what? I think I missed the semicircle. Well, I just answered that question right there. Again, ADE would be a semicircle, ABE, same thing, AFE, FAB, those are all semicircles there. So hopefully you're catching on to that. For the key concept down there, this is just reiterating what we talked about earlier. The measure of an arc is equal to the measure of the central angle. Okay, the measure of the arc is equal to the measure of the central angle. Okay. So in this last problem here, it's really simple, so don't make it more complicated what it has to be. What's the measure of this arc up here? That's for number 1. Well, it's equal to the central angle, so I can put 32 down. In fact, I would probably work my way around and fill in all the missing parts before I even answer them over there. If I go ahead and take 180 minus 58, I get 122. And we know that these are the same. 180 minus 32 would give me this angle over here, 148. So this is 148 over here. Okay. So when I look at arc BC, again, number 1 is 32. Arc BD would be the sum of these two. 32 plus 58 gives you 90. Arc ABC, if we start here, go all the way to there, well, you know what that looks like. That's a semicircle. That's 180 degrees. Okay. If we look at arc AB, we've already found that one. There's your 48 degree. Angle COD, again, knowing that they're equivalent, 58 degrees. Angle, or arc CDA, well, there again, it looks like a semicircle, straight line across, diameter, 180 degrees. Arc AD, well, we've already got that because that's equal to the interior angle here. And arc BAD, and if we do that, adding this arc plus this arc, we have 270, yeah, 270. Now, you could have added these two arcs, which is what my first thought was, but you could have also taken this arc over here, which we knew was 90, right? And subtracted it from 360 and got the same answer there, okay? So again, it's a quick run through on today's lesson. Again, I don't think it's a tough lesson, but I wanted to make sure that you had all the information so you can get your homework done. So make sure you have this done for tomorrow. I appreciate you listening, and I will see you later. Have a good night.